This one's actually not, it doesn't really need the TI-83 necessarily, but there is a way to do it with it, and since most of you have it, I'm going to go ahead and show you. But the D bar means the difference between the X and the Y. So here the difference between this is -1, the difference between this and this is -1, so on and so forth. And you're going to take the average of all those differences. So it's the average of the differences. Here's how we use the calculator to do it. I've already entered the data for us to save some time. List 1 I put the X's, and list 2 I put in the Y's. Now here's how you can use the calculator to find those differences. If you go over to list 3, and then if you go to the up arrow, you can actually tell it, I want to take second, list 1, minus second, and then list 2. And what that'll do is it'll take, and you hit enter, it automatically calculates that 14 minus 15 is -1, and 7 minus 10 is -3, and so on. So it's found all those differences. So now if we want to find the average of list 3, we hit stat. We're going to go calculate one variable stats. And we want one variable stats. We want the stats for list 3. We want the average and standard deviation. So you have to do second and L3. That way it knows what to calculate. All right, so we get that D bar, the X bar is -1.25. So that's what we'll put here. So again, based on what the calculator said, that average of the difference numbers was -1.25, and the standard deviation was as the next question, it was Sx, and it's 2.375 to 3 decimal places. Now we need to find the test statistic. All right, we can do the calculator for this as well. So what we need to do is we need to do stat, and we're going to do just a plain t-test, nothing fancy here, just a t-test. All right, and so what we're going to do is we can leave it on data, and we're going to assume that the mu, the difference between these, is 0. That's the assumption, that there's no difference between these pairs of data. All right, so we leave that as 0. We're going to change list 1 to list 3, and then we're going to assume that it's not equal, and we'll calculate. And so there, the t-value is what we type in next, and it's -1.488 to 3 decimal places. Now, t alpha divided by 2 is where we find what is the critical t-value against which we must compare. So let's go get the critical values of t table and bring that in so we can see it. All right, so we have our distribution of critical t-values. So what we have is a 0.05 significance level. So the area in 2 tails is 0.05. Now the reason we do 2 tails, just to kind of refresh, is that we said for these questions we always assume that it's 2 tails because there's some difference between the mean, between these two numbers, and so all we want to know that it is not equal. All right, so not equal means 2 tails. When it's less than or greater than, that's when you have 1 tail. All right, so that goes with that, and then this goes with 2 tails. All right, so we're assuming not equal, so we need to go down this column, and we go to degrees of freedom. So recall for a t-test, we go to n-1 degrees of freedom. So we had 8 values here, if you count them. So we go to row 7 for degrees of freedom, and we come across, and our critical t-value is going to be 2.365, and that's what goes here. And now technically that's the end of that question as far as getting all the credit. But what we would normally do after we've done this is we would compare this t-value to the critical t-value. And since -1.488 is not less than -2.365, we would say in this case that there is no significant difference. So again, we check that our t is less than the critical t. Right. Since it is not, we fail to reject or say there's not sufficient evidence in a conclusion statement. But again, that's not part of this problem. But as far as getting credit, but that is part of the conclusions that we check. We check that this t, whether it's less than or greater than, in this case it could be greater than 2.365. Since it is not, we fail to reject.